Here we're going to take a look at a software tool we use frequently in physics, and that is graphical analysis. We can input data points that we've collected in labs and explore relationships between the data quickly and easily. So we've collected some data of a spring. We pulled it different distances and measured how much force it took to hold it at these distances. And so the first column there is the distance we stretched it, that is the x, and the second column is the force that the spring responded with. And so the thing we're in charge of, how far to stretch it, goes in the x, and the thing nature responded with, how much force, goes in the y. And so you can see we've already made our plot, but there's some things we need to change here. We don't want these connecting lines, and we want to make some other changes to the graph. And so when we want to make changes to the graph, we just double click on it and a window comes up. And so I can get rid of those connecting lines by unchecking that box, and I can give the graph a title, force versus distance for a spring. And then also we want our axes to go through 0, 0. If you look, the y-axis doesn't quite go down to 0, so we can press axes and auto scale from 0, or I could select manual and input whatever I wanted. And so now you can see we have all our data, but there's another problem. We need to label the axes. X and Y won't do it, and so I just double click on the data set. I clicked on the X, and I'll give that a name, call it distance. Displacement would be okay. X is a good short name, and the units were meters. Have to have your units. And then click on the Y column, and that is force. Short name F, and the units were newtons. And so now we have a pretty good graph, but we want to explore the relationship. You can see it's a very linear relationship, and so we can have the program fit a curve to that by going to Analyze and picking Linear Fit. That gives me a best line fit based on the least squares algorithm that minimizes the square of the distance of each point from the line, and it gives me the equation of that line. And so y equals mx plus b, where m is the slope, 49.7 newtons per meter, and the y-intercept very small, pretty much negligible, which makes sense. If we don't stretch the spring, it won't respond with a force. The slope also has meaning. 49.7 newtons per meter means if I stretch the spring 1 meter, it'll take about 50 newtons to do that. If I stretch it 2 meters, it'd be 100 newtons, or a half meter, about 25 newtons.